This is Bob Capetta from the College of the Florida Keys, and this lesson is a review for the second test in Calculus 1. So the first question I'm going to look at is x cubed plus y cubed equals 4xy plus 1. And our goal is to find dy dx at the point 2, 1. We'll do that by taking the derivative with respect to x of all pieces. So the derivative with respect to x of x cubed plus the derivative with respect to x of y cubed equals the derivative with respect to x of 4xy plus the derivative with respect to x of 1. Now, the derivative with respect to x of x cubed is just 3x squared. The derivative with respect to x of y cubed would be 3y squared dy dx. Equals the derivative with respect to x of 4xy is going to require us to use the product rule. So we'll say u is 4x, we'll say v is y. U prime is the derivative with respect to x of 4x, which is 4. V prime is the derivative with respect to x of y, which would be dy dx. So of course we get u prime v plus uv prime, u prime v 4y plus uv prime plus 4x dy dx. And then we get plus the derivative with respect to x of 1, which of course is 0. Now let's get all of the dy dx's on the left side, so that will be 3y squared dy dx minus 4x dy dx equals, on the right side, we are going to have what? 4y. Move that to the other side, minus 3x squared. Factoring out the dy dx, we get dy dx times 3y squared minus 4x equals 4y minus 3x squared. Then divide both sides by the 3y squared minus 4x. And we have a simplified version for dy dx. dy dx is 4y minus 3x squared over 3y squared minus 4x. But I'm interested when x equals 2 and y equals 1. So we should plug 2 and 1 into that and see what we get. Can we read the screen here? We could try at least. So I'm going to say 2 store in x. And I will say 1 store in y. And I will plug in 4y minus 3x squared divided by 3y squared minus 4x. And the result I get is 8/5. So my answer to that is the slope dy dx at the point 2, 1 is 8/5. So that is a fairly standard implicit derivative question. Let's go ahead and do a slightly more challenging one next. Here I have the tangent of x minus 3y is going to equal y over 1 plus x squared. We're going to take the derivative with respect to x of both sides to find dy dx. That's our goal. So take the derivative with respect to x of the left side and the derivative with respect to x of the right side. The derivative with respect to x of the tangent of x minus 3y equals the derivative with respect to x of y over 1 plus x squared. Now, the derivative of the tangent of something is the secant squared of the something. Secant squared of x minus 3y times the derivative with respect to x of the argument of the function of x minus 3y equals the derivative with respect to x of y over 1 plus x squared. That is going to require the quotient rule. So what we'll say there is we'll say u is y, we'll say v is 1 plus x squared. U prime is the derivative with respect to x of y, which would be dy dx. V prime would be 2x. So normally we get u prime v minus u v prime over v squared. What will that be? U prime v dy dx. V 1 plus x squared minus uv prime minus y 2x or 2xy all over v squared all over 1 plus x squared squared. So continuing our work here, we get secant squared x minus 3y times the derivative with respect to x of x is 1 minus 3 times the derivative with respect to x of y would be dy dx. Equals all of this on the right, which I'll rewrite as 1 plus x squared dy dx minus 2xy over 1 plus x squared squared. So we have a lot going on here, a lot of tedious algebra. Let's multiply both sides by that denominator so that my next line becomes secant squared x minus 3y times 1 plus x squared squared times 1 minus 3 dy dx equals 1 plus x squared dy dx, or maybe let's distribute here. 1 times dy dx is dy dx plus x squared times dy dx, x squared dy dx minus 2xy. Again, lots of things happening. Let's distribute this times 1 gives me secant squared x minus 3y times 1 plus x squared squared times 1 minus 3 times secant squared x minus 3y times 1 plus x squared squared dy dx equals all that stuff on the right side, dy dx plus x squared dy dx minus 2xy. So where to next? Let's get all of the dy dx's on the right side. So I will move this to the right side, and all of the non-dy dx's on the left side. I'll move that negative 2xy to the left side. So what I am left with then is the negative 2xy comes over to the left side, becomes positive 2xy plus secant squared x minus 3y all times 1 plus x squared squared. And then on the right side, I'm going to move that over, so it'll become positive 3 secant squared x minus 3y times 1 plus x squared squared dy dx plus dy dx plus x squared dy dx. Let's make sure we see all of that as one line. And then our next move is to factor out the dy dx on the right side so that we will have the following. Make sure you can see it. The left side will be 2xy. I'm going to rewrite this as plus 1 plus x squared squared times secant squared x minus 3y, just to make it a little cleaner, equals dy dx times all of this stuff, which I'm going to again write 3, 1 plus x squared squared, secant squared x minus 3y, plus 1 when I factor out the dy dx plus x squared. And then my last line is to go ahead and divide. So my final answer will be 2xy plus 1 plus x squared squared, secant squared x minus 3y divided by 3 times 1 plus x squared squared times secant squared x minus 3y plus 1 plus x squared equals dy dx. And indeed, that is a pretty challenging question. But the challenge comes with the algebra, much more so than with the calculus. We're going to continue our discussion on implicit derivatives, and we'll take a look at a second order implicit derivative. So this time, we are given x squared over 25 plus y squared over 9 equals 1. And our goal is to find the second order partial derivative. So the first step is to take the derivative with respect to x of each piece. The derivative with respect to x of x squared over 25 plus the derivative with respect to x of y squared over 9 equals the derivative with respect to x of 1. So this first piece will give me 2x over 25. Second piece will give me 2y over 9 dy dx. The derivative with respect to x of 1 is 0. We're going to need to solve for dy dx, so let's add negative 2x over 25 to both sides. So we get 2y over 9 dy dx equals negative 2x over 25. Now let's multiply both sides by 9 over 2y. Multiply the left side by 9 over 2y. Multiply the right side by 9 over 2y. And we get that dy dx is what? Is the 2's cancel. Negative 9x over 25y. But that's not what we're asked for. We are asked for our second derivative. So if we're going to find the second derivative, how are we going to do that? We're going to take the quotient rule again and see how that behaves. So in that instance, we're going to have u is negative 9x. V is 25y. U prime with respect to x is negative 9. V prime with respect to x would be 25 dy dx. We know our usual rule is what? Is the quotient rule is u over v prime is u prime v minus u v prime all over v square. U prime v, negative 9 times 25y minus uv prime minus negative 9x times 25 dy dx all over v squared, all over v squared, all over 25y squared. So what's that going to give us? Negative 9 times 25 is 225, so negative 225y. Plus 9 times 25, 225x dy dx. All over 25 squared, which is 625. But that's going to make that a lot easier to simplify. So if I divide these out, 225 over 625 is 9/25. So I get negative 9 over 25y plus 225x over 625 is again 9 over 25. But here we get x over y squared times dy dx. But we know what dy dx is. Dy dx is right there. So my second derivative is all of this. d2y dx2 equals all of this. So that my second derivative will become negative 9 over 25y plus 9x over 25y squared times dy dx times negative 9x over 25y. Let's try to simplify that if we can. So that the second derivative becomes if we get our common denominator, let's multiply top and bottom by 25y. Negative 9 over 25y times upstairs, downstairs. By what? By 25y squared over 25y squared plus 9x times negative 9x, that's negative 81x squared over 25 times 25, 625y cubed. So we have a common denominator now. So what is that going to give me? We have negative 225 y squared over 625y cubed minus 81x squared over 625y cubed. And we put those things together, that gives me negative 81x squared minus 225y squared over 625y cubed. And that answer is acceptable. Now, there may be a way for us to simplify it if we go back to our very original question and see how that behaves. But I think I'm satisfied with this. The algebra here is miserable enough. So let's go ahead and call that our solution for our derivative, our partial derivative. And let's do one more here with implicits before we finish this video. And that is going to be to use implicit derivatives to find the derivative of an inverse trig function. So I'm going to look at y equals the inverse sine of 3x, and the goal is to find dy dx, which would be the derivative of the inverse sine function. So if that's the case, let's rewrite this problem as sine of y equals 3x over 1. We can then draw a triangle Sine of y is opposite over hypotenuse. Opposite is 3x, hypotenuse is 1. I want to find the third side of this triangle, call it b. So b squared plus 3x squared is 1. B squared plus 9x squared is 1. B squared is 1 minus 9x squared. B is the square root of 1 minus 9x squared. So we've successfully constructed a triangle for this. Now again, we have sine of y equals 3x, and our goal is to find dy dx. So how are we going to do this? Sine of y is 3x. Let's take the derivative with respect to x of both sides. The derivative with respect to x of sine y is the derivative with respect to x of 3x. Derivative of sine y cos y, dy dx equals 3. So dy dx equals 3 over cos y. Well, what is cos y? Looking at our triangle, cosine of y is adjacent over hypotenuse. So cos of y is our adjacent, root 1 minus 9x squared over our hypotenuse of 1. So my answer for dy dx is simply 3 divided by the square root of 1 minus 9x squared. And that will complete this review set of problems focusing on implicit derivatives.